Okay, so this is a real quick explanation of the Pokemon Yellow any percent speedrun and exactly why it actually works, because it's not the most obvious thing. Though probably the easiest way to start is with, there he is. So this is Pokemon Yellow on an emulator real quick. I should say right away, this will only take a couple minutes. As opposed to most speedruns. It's one of the reasons why this game is the only one that doesn't really have an any percent category, because any percent just takes such a short amount of time. So I'm going to real quick break one of the first rules of gaming, and I'm going to quit while saving. It's a bit jank. Right. So there we go. You have a couple frames, so this sort of golden window to tab out. And we'll see if we... Okay, fair enough, I actually did it. It's a bit tricky to do, but okay, and then all you need to do is just go into your Pokemon screens, just switch about a couple of them, like this, of course. And then you go to your item screen, take this item, drag it down just a little bit, go through this mess, and then pop it down here, toss a couple. This is also very, very important. Close out all the screens, go for the door, and that's time. So there we go. We're now in the final room of the game. This is where I'm being congratulated for being such a good player. And all we've got to do is just tab through some boxes, and there we go. This is the end of the game. Hopefully, I was a bit slow. You can do it in 0-0 if you're quick enough, but I haven't done very well on filling out the Pokedex either. Oh well. The next question is, what on earth was that? How could such a random sequence of steps lead to the end of the game? And I'll try and quickly detail why that is. So to start with, it's good to establish a goal. What are we sort of working towards in this sequence? So there is an address in the game's memory, or actually maybe this is an academic talk. There's an address in the program's memory, which stores the location you should go to when you exit out that door. It's address number D364. Remember that, this will be important for later. So normally it's set to just 0, which is outside, but if we could set it to 76, or 76, it's hexadecimal, and then leave out the door, we'll be sent to the sort of Hall of Fame room to the end of the game, and we win. So this is what we need to do, but of course normally you're not normally allowed to just edit memory. So we have a couple steps we've got to do first. The first thing is break our save. So this is a real quick representation of the save. It's a bit bigger than this, but this is all that would fit on the slide. And it's when you reset the game, it's all blanked to just Fs. And when you save the game, it's actually a bit more complicated. There's actually sort of 3 separate procedures the game will do to complete the save. So firstly, it will save all of your sort of player data, like your name, playtime, that kind of basic stuff, and that will go at the top. And then it will save the box data. If you're not aware, the boxes are sort of these mass Pokemon storage, so you don't have to carry them all around on you at once. And this takes a few frames. And because you haven't actually done anything yet, this will do nothing at the start of the game. And then finally, it saves the Pokemon you have on you, your party. You can sort of hold up to 6 Pokemon that actually do the fighting in normal gameplay. This will do also very close to nothing. But there is this notable address here at the very start, which stores the sort of current size of your party, the number of Pokemon you have on you. And this will be set to 0 because you've just started and you don't have any quite yet. But what if we try to break out of this a little bit? So after the player data has been saved, and while the game is taking some time to save all of the box data, which doesn't do anything, what if we were to reset at that point, which is what we did? We'll end up with this save file, which has all of your player data set correctly, but most importantly, your Pokemon count was not set back to 0. It's still FF, or 255. And the game now believes you have 255 Pokemon on you, which leads to some undefined behavior. But, okay, hold on a minute. That seems a bit too easy. Surely the developers, they would have thought of that someone might try and mess up. And they did. They implemented what's known as a checksum. where, to put it very briefly, a checksum will take this whole save file and compress it down to just a couple bytes. And the sort of main idea is that 2 different save files will result in 2 different checksums. The more CD you might notice, I've actually just taken the first 4 bytes and used that as the checksum. Though in reality, it'll be a bit more complicated than that, and we'll use the entire thing. But this will do for our purposes, for our checksum. So how is this used? Well, when the save completes, the last thing it will do is calculate the checksum for your save file and save that as well. And then when you load back up the save file, it'll take a look at the save file, recalculate the checksum, and see if that's one the same as the one that you just saved. If they do match, then OK, it's a valid save file. And this is a problem, because of course we never complete the save, because we quit halfway through. So the checksum will never be recalculated and set. And so when you try and load this file, it'll calculate a different checksum, and it'll say, your save is invalid, this cannot be loaded. So, drat. No speedrun for us today. Except not quite. They messed up. I mentioned before, saving is actually these sort of 3 procedures. And for whatever reason, these are so separate procedures that they will recalculate the checksum at the end of each one. The reason why this is in case you only wanted to sort of run one part of the save, you would still recalculate the checksum when you're done. The amusing thing being that in reality, this is basically never done in the game. You'll always save the entire thing, except for some really niche situations. But this is the design decision that the developers made, and this gives us an opening again. Because let's say after you save all your player data, it will finish that procedure and recalculate your checksum. Neat. And while it's saving the box data, the other crucial thing about this is that empty box data and the default sort of Fs there are the same. This will do nothing for a couple frames because it just sort of sets everything to blank. And so it won't mess up your checksum. So if you were to quit during this point, well, would you look at that? We now have a save file which has a valid checksum, but also has this incorrect count. And just like that, we've managed to mess with one value in the game, and this gets us a little closer to breaking it. But OK, that's step one. So we've now loaded up our broken save file, and this is now this is a view of the kind of working memory of the program. So right now it's probably pretty meaningless. We need some labels for this. So the developers intended you to view this data like this. So the first 6 rows, each row is sort of allocated for one Pokemon, and then after that comes some stuff about your bag, which is where you sort of store all the single-use items in the game, and then after that comes some sort of miscellaneous info. And that's just sort of how things are meant to be seen. But say you're the Pokemon viewing screen, and you believe the player has 250 or so Pokemon, and you look at this data, you're not going to see that as what the developers intended. You're just going to see more Pokemon. Because why not? Data is data, and it's up to you as to how you'd like to view it. And because the program will try and see this as just for Pokemon, you can do sort of Pokemon operations to it. You can even teach a move to bits of data in the game, which is bizarre, but not something we can do right now. All we can do is just swap them around. Of course, one other important thing here is the highlighted value here. That is our address number D364 that we're trying to overwrite. It just so happens to come right after the Pokemon in the game's memory. Life's little coincidences. So if we were to perform a swap in the screen with number 2 and number 8, we'll get in this situation where, OK, we've now overwritten the golden value, but it's not quite right. We've overwritten it with just FF when we didn't want that. We want 7.6. And also, we just overwrote a bunch of other kind of important miscellaneous information about the game, which will probably cause a crash, and that won't lead to a time. So that's not too good. We need a more fine-tuned way to edit this data. And thankfully, we do have that, which is the bag. So OK, we need to mess with our bag a little bit. Right now, it's completely valid, and we need to change that. And the way we can do that is by the other highlight value here. This is where the game stores the count of items in your bag. So right now it's set to 0 because you don't have any yet. But if you were to do another swap, oh, look, just like that, we've now got 255 items in our bag. And we can now do some operations there. So it's basically the same trick, but now we're doing it with the bag. But OK, the last bit, we now need to do some item manipulation to get things just in this position. So this is a sort of more zoomed in version of the last slide. The sort of last 2 lines there are what we're showing here. This is also the actual data in the game. I went and copied out for authenticity. And one carry from that is that we still have let's go in the slide. OK, is that this data is the miscellaneous data. But say you're the bag screen and you're trying to display 250 items or so, you're going to see, though the miscellaneous data, you just more items. And items are really simple. They're just stored as an ID and a quantity in 2 bytes next to each other. And the important item here is number 36 down there, whose quantity or whose amount just so happens to be stored in address number D364. So we can do some swapsies to move data to where we want it to be, because items, you can swap them and you can toss them. Those are the 2 things we can do, but that's actually enough. So if you look at item 6 over here, which is just which should be part of your normal bag, and swap it with 36, well, OK, a bit closer. We've now set it to 81, so last thing to do is just toss a couple of them, and there we go. We just set address number D364 to 76. And because of that, we can now just close all the menus, walk out the door, and we just beat the game. So there you go. There's a real quick illustration on what happens if you treat data in many ways other than what you just intended, and, I don't know, program better so you don't leave exploits in. This is rather just scratching the surface of what you can do in Pokemon Yellow. The games are very broken. You can do stuff like this or this, which is delightfully explainable if only I had enough time. Unfortunately, I don't. I'm probably out of time, actually, so I'll have to end things there. But I thank you for listening, and I welcome any questions.
Thank you.